Hello everyone, this is the Viking Initiative. Still, this is the AP Calc BC course, and then we're gonna be talking about the U-substitution today. We'll be focusing on like how to use U-sub stuff, and then why I included this. Somebody might think this is simple, but sometimes it's not simple. There's a lot of variation within this. And then also, this is just throughout the whole course. From every unit after we learn integration, I think U-sub is so important. And this is the most important integration technique in this course. There's also other substitution like trig subs, and then maybe other integration by parts, those stuff, but those are not as important, and we're not gonna even touch about trig sub in this course. And then for those U sub, it's just all everywhere. So I gotta make sure everyone knows how to do this. That's why this concept video is made. So like, what is U-sub? It is just like a reverse chain rule, where chain rule we're having something we finding like gx is u, and then after we did the derivative of this u, we're also gonna do the derivative of g of x, and then here's just the opposite. We're gonna divide by the derivative of g of x, and then it's just gonna make integrals so much more simpler. This might sound a bit confusing, but for those you know, or like when you're going into the problems, you'll know what I'm talking about. So some of those steps is, first of all, you're gonna pick a substitution. So you're gonna let u is gx, where g of x is part of the integrand, which is the thing inside the integral. And then we're gonna differentiate, which we find du over dx, or we're gonna rewrite like du is the derivative of g of x times dx. And then we're going to try to replace all x and dx in terms of u and du. If you fail to do this, this is the incorrect U-sub. And then now last, we're just going to integrate for u, and then we're going to always substitute back x into u if it's a indefinite integral. If it's a definite integral, we're talking about in examples. And then also, okay, first simple example is the integral of 3x squared plus 1 to the fifth times 6x dx. And then what we're going to do is simple, right, straightforward. We're going to take u to be 3x squared plus 1. Then we do du, which is 6x dx. And then what we found out is 6x dx is du, and then we have 6x dx over here. Then we substitute that into du. So it's u to the fifth du equals to u to the sixth over 6 plus c. And then what you're going to do is just substitute u back into this ugly stuff. And then simple example 2, which is cosine 2x dx, where 2 cosine 2x, a bit hard to deal with. If it's cosine x or cosine u, it's going to be perfect. So, of course, we substitute 2x with u, not the whole thing. Then we will find out du is 2 dx. Then what we do is we found dx is du over 2. Then we have dx over here. So we plug in dx as du over 2. Then looking here, we take the over 2 to 1/2 in the front, then out of the integral, then we do the integration of cosine u, then which is 1/2 sine u plus c. Then you plug 2x back in for u, making 1/2 sine 2x plus c. Yep. And then though this is one of those AP style questions, what we found different is we have bonds here. This is a definite integral. And then we have the integration from 3 to 5 of 2x minus 3 over square root of x squared minus 3x plus 1. So what we're going to think about here is, after u sub, does the bound changes? Obviously, yes. So how do you change those bounds? Think about this. Maybe I'll tell you, like, just plug in 3 and 5 into the thing you want to u sub, and then this is going to be the new bound for u. And then from there, we can just follow intuition and then just try ourselves. I will show the answers in 3, 2, 1. Okay, so what we did here is we take u as everything inside the denominator and the square root, which is x squared minus 3x plus 1. Then we do the derivative on both sides, which is du equals to 2x minus 3 dx. And then here we did an important step, is changing the bonds. What we do is we plug in 3 and 5 into x squared minus 3x plus 1. Then we'll found 3 give us 1, and then 5 give us 11. This is our new lower and upper bound, 1 and 11. Since we changed the variable from x to u, the bonds must change following. And then what we do is just the same thing as u sub, 2x minus 3 times dx is du, as in here. So we replace this with du. So this will give us the integration from 1 over 11 for 1 over square root of u du. And then we do the simple integral. This should give you 2 times square root of 11 minus 1. So if you're not mastering u sub, like you're not doing this like super easily, I always recommend after you do the u sub, you always plug in the values for the bonds into the thing you do the sub, which we call changing the bonds. So you do not have to change it back to s again, since more step you change, the more chance you do it wrong. So changing the bonds after u sub for a definite integral is always recommended for me. And then this is a second AP style question. This is a specific type of U-sub. I failed to find them online. I don't know why. Maybe it's my research was like very, very, very bad. So this is made by me, like, because I cannot type integral written by ChatGPT, and then solution is written by me. So this won't be as hard because I do not have a lot of time to develop this, but I'll just give you guys a hint. This is not like a directly forward U-sub. If you very, very want, you might do this with long division, but I recommend try with U-sub. Like, think about what should you substitute with U. This is maybe the other kind of U-sub. And then I'll try pause the video and do it yourself. I'll show answers in 3, 2, 1. Yeah, here what we did is we replaced x minus 1 with u, and then dx is du after we differentiate both sides. Then it changes from the integration of u plus 1 squared over u squared. And then what we did is we expand the square on the top. It's u squared plus 2u plus 1 over u squared du. Then we split up the numerator into 3 parts, and then divided by u squared, which give you as 1 plus 2 over u plus 1 over u squared, which I written as u negative 2 du. Then it's just simple integration. We integrate by both things. It's u plus 2 ln u minus u to the negative 1 power, and then plus c. And then always remember, just replace u with which you substituted. And then what I think is the hard stuff here is just think about x minus 1 as u. Just sometimes you do not have to substitute a lot of ugly solutions. Just substitute like a simple thing here. So since in this, the denominator is very, very complex, this is what we do not want to see. We want to have the upper be more complex and then the denominator be more simple, so we can separate like a fraction into multiple ones, or even just break it down as what we did. So like in this case, it is just much more easier for like a u plus 1 over u squared in this case. Then we do a u sub for x minus 1, just making it much more simpler. And then also, like, just last thing I want to say about this question, after you replace x minus 1 to this u, this negative minus 1, it don't stay. Because there's a plus c, this negative 1 it just goes into a plus c. It just bonded. So the final answer should be x plus 2 times ln x minus 1 minus 1 over x minus 1 plus c. This negative 1 should not exist in your final answer. Just the last thing to making sure. And then the final AP style question is this. This is much more straightforward. The only thing is it does not cancel out like very, very perfectly after you do U sub. You need to consider one more thing. And then I trust you, all you guys can do this after all those questions. And then just pause the video and try. I'll show the answers in 3, 2, and 1. So what we did here is u equals to 4w squared plus 6w minus 1. Same thing, we do the integral. No, not integral, we differentiate both sides, which du is 8w plus 6 dw, but we only have 4w plus 3. So we need another 2. So we assume we have that 2. So du is 2 times 4w plus 3 dw. So 4w plus 3 dw is 1/2 du. Then we plug this in. So it's 1/2 the integration of 1 over u du. Should give you 1/2 ln u plus c. And then always remember to plug in u, all this stuff back into here to get all the marks. And then, yep, that's it for today. So if you guys have any more questions, visit our Viking Initiative websites. And then if you want to further reach out to our tutors, join our AP Calculus BC study group, and then there will be tutor helping you in WhatsApp. Just thank you so much for just listening.